Alright guys, before we talk about blueprint communication, we have to go over flow control. I realize it's a little bit more important to first understand how the flow works so that you could perhaps utilize stuff like, I don't know, arrays and working with other types of combinations of objects. So here I've actually created all of the flow control relevant nodes, but I did it in player controller so that we could call upon them, based on a button press. So as you can see, it's currently empty, but I've kind of separated them in three categories. These, of course, are, and like they're not 100% accurate, aside from the loops. These could have easily been in the same category. But the loops are essentially the stuff that you use to go over arrays. Whenever you talk about arrays, usually you'd be talking about a loop as well, with a few exceptions. You can use a for loop for something else other than an array. We're going to start with the execution path because I think it's the easiest one to understand. So I'm just going to drag this over on this side, and we'll simply go through all of these, and we'll need a trigger. So I'm just going to grab spacebar again. As you can see, there's my keyboard event, which is spacebar. And we're going to simply hook this up one by one and see exactly what happens. Now, we're going to start with the flip-flop, because flip-flopping is, well, it depends on what you really need. I mean, that's the whole reason of this whole execution flow. All of these nodes here are simply there so that you could perhaps, do something that, let's say, you're required to do something, and you simply need to split or stop or somehow prevent the execution flow. And these are the nodes that you use them. So let's go over them in this video. That's what we're going to be going over in this video entirely, by the way. So I'm going to drag this over and say, when I press spacebar, I want to flip-flop. You want to use flip-flop, and basically I'm going to have two print strings, 1 and 2, and this one is going to be hello, this is one going to be goodbye, as you can see here. Let's make this a 15-second print string, and let's make this a 15-second print string. Let's make this red and this green. So, it's very easy to distinguish between them. If only I did not overlap them, that'd be nice. So there are our print strings. Now, the cool thing about this is that it essentially is going to swap these two. And what I need is some kind of actually, I don't need anything. Let's just hook it up and see what happens. So here, every time I press spacebar, there'll be this execution pin will fire and send an execution command to the flip-flop. Depending, of course, on what it is, it's going to first fire A, then it's going to fire B, then fire A, then B, then A and B, etc., etc., etc. You will notice as well that it has a boolean here called is A. Now this is essentially for some logic that requires you to get a boolean. For example, it could be a branch. In other words, this is going to fire off a false or true, true or false, and you could use that in a branch. We're going to go over a branch just in a little bit. I simply want you to show the flip-flop first. So let's play. And I'm going to press spacebar. It says hello. Spacebar says goodbye. Hello. Goodbye. Hello. Goodbye. Hello. Goodbye. Hello. Right? Very, very, very simple. You could also obviously, look at this in a more traditional sense, and that would be, I believe, by playing in editor. Yeah, we are playing in editor right now. Play this here. Essentially eject from whatever it is we're doing, and now if I press spacebar, I should be able to see the debug. Okay, I need to possess this guy again, and I need to drag this over to this side because currently we're simulating. And now if I press spacebar, you'll see that it's being fired depending on the position. I think I need to kind of make this a little bit more appropriate. Maybe if I used something else other than a spacebar that requires input, I would have. There it is. We're firing off. Right, very simple. I'm not going to bother with this in the future. Actually, I think the debugging this is kind of a pain in the ass. Generally speaking, you might want to have a second monitor where you can watch the debugging in real time whenever you're simulating. Anyway, that's how the flip-flop works. Now, here's the branch. We could use this condition here, by the way, and say, All right, let's grab this branch. And we're going to use this condition. I'm not going to promote this to a variable or anything, but this is essentially an if statement. And it is what it is, right? So I'm going to grab this condition, going to clonk it over here in the branch, and I will execute it on both sides. So whenever we're firing off, we want to see if whatever we fired off is, is A. So we're going to run some kind of logic depending on if it's A or B. So if it's true, I'm going to do something. So print string again, print string because it's the easiest basically node for debugging. So print string again, and it's going to say hello. And if we're using A, it's going to fire off of this side, and this is going to be true. It's going to go here, and we're going to say hi as well. Okay, and this is going to just simply stand for 15 seconds as well. I'm going to copy this, and over here, maybe I need to change the color of it, but just keep it as bye-bye. Right, very simple. And as you can see, the difference is minimal, but the results are going to be different depending on the flip-flop itself. So I'm going to compile and play. So press spacebar. You can see hello, hi as well. Spacebar, bye-bye. I mean goodbye, bye-bye. So this will essentially be returning true or false, and whenever it returns a true, it'll fire off this way, and when it returns a false, it'll fire off this way. So far, so good. Next, you have a sequence. Now the sequence is it's a very good node because it allows you to split the main execution line. The main reason I do it, for example, is if I want to split the event tick, because event tick, not trick but tick. Come on, just tick. Okay, so the event tick is kind of like this central line where you'll be executing stuff that needs to be done every single frame, and sometimes you might need to execute more things. So in this case, maybe I want to have several print strings. Now obviously this is not ideal because this is going to just simply flood the the print screen. The screen is going to be flooded with a bunch of these, but let's just say this is hello, and this is bye, and this is eat, and this is sleep. All right, so I got several executions. I got 4 execution pins, and what this is going to do is going to execute this stuff in order. Now the thing is, it's going to happen so fast that to the player this really doesn't matter. Like even though they are in order, they'll be executed so fast that really you wouldn't really have that many things to worry about. So if I just compile and play, you'll see that we have buy, sleep, eat, hello, buy, sleep, eat, hello, right? It'll be, well, hello, eat, sleep, and buy, because first one is hello, then it's eat, then it's sleep, then it's buy. Now, to illustrate this example a little bit better, what if we grab the sequence and let's just say, actually I should have just grabbed the whole thing here. All right, we're going to grab these and simply move them out, and we'll hook this up on this side. So whatever we do, we want to fire a sequence. Doesn't matter if it's true or false. Currently, we've got a bunch of prints, so this needs to have some other significance. So I'm going to say this: I am first. I am first. Here I'm going to say I am second. Here I'm going to say, of course, I am third. And here I'm going to say, not third, but third. Got to get myself, I'm telling you, these membranes are killing me. And of course, I'm fourth. Now if we compile and play, we're going to fire this off, of course, by pressing spacebar. Press spacebar. We got, I'm fourth, I'm third, I'm second, I'm first. Hello as well. As you can see, it's being fired at the same time. Even though I only press it once, the execution gets fired 4 times because I'm splitting it 4 times, right? So that's what you'd be using a sequence for. Next, you've got a gate. Now the gate bit is fairly interesting because I actually rarely have to use it myself. but it's a lot like an if statement where you simply have another condition which allows you to toggle it or close it. Now, unlike an if statement which fires off, which is in this case a branch, remember. Now the branch is going to fire off depending on the condition. So if it's true, it's going to fire off the true branch. If it's false, it's going to fire off the false branch. Now if you have a condition that is a lot more complex, you'd be using the gate itself, and by proxy the multi-gate. The difference being that the multi-gate is, it's got several gate outputs, whereas the regular gate has only one exit. Okay? And the thing is, you simply need to grab something. Let's say I got a condition here, and if it's false, right, in this case, I want to, I don't know, toggle the gate, right? And of course, you need to enter through it. So let's say I enter through it every time I release. Okay, so every time it's false, I'm going to toggle the gate. I'm going to start close so that nothing will happen, right? Instead of, obviously, I could have specific logic for opening and closing. I'm going to print another string, and I'm going to say, just got gated, and this will be, of course, 15 seconds. I really should change the default duration of stuff, but generally you don't want to bother. And I'll make this pink. Okay, so as you can see, we've got a very simple setup. Whenever I release, this will fire off, and if the gate is closed, you should see it every second time, because every second time this will be false, and because it's false, every second time this will toggle the gate. Compile, play. So I press once, nothing happens. Press twice, there we go, just got gated. Press once, just got gated. It just replaces it. Okay. Because first, you see, because we get it twice is because first it's open, then it needs to close, then it needs to open, then it needs to close, right? Because if you remember, execution is important in terms of its in terms of the execution order. So in this case, because I'm firing this off when I release it, right? First it's going to fire, and then it's going to do this logic, and then it's going to toggle it. And so basically I get to do it twice. If I, for example, hook this up in a different fashion, I simply grab the final result here, which would be, let's say, I don't know, first sequence maybe, or something like that. Maybe over here from the hello. Oops, 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 oops. Where is it? Now, this is, of course, not how you would create your spaghetti sauce. That's definitely not ideal. But if I play this now, you should see that we got a different result here. But in this case, because we're doing this after the logic, then we're getting different fires. And also, that's because we kind of forgot to hook this up. Forgot to do that. Now, in this case, actually, you would want to use a sequence if you want to fire a false into both of these, actually. That's a good point to be made. So let's say I take a sequence, and I use the false, and then of course I first fire off the regular string, and then I combine that over here. What was it? Only the false toggle, and let's use the released again, like this. So let's compile and play. Now we have a different behavior. See, so this gate really is, the way you put your gate and how you use it is kind of important. But then again, I never did have to use a lot of it myself because, frankly speaking, I find a lot of my logic is, is just fine by using branches and sequences and sometimes, obviously, other things. But in general, the multi-gate is something really specific. Like, I don't know how many times you'll have to use the multi-gate yourself. But it's just like the regular gate. We have an input, and you have something to reset the the count. But essentially, first is going to go through the first one, the second one, the third one, and then of course we can loop around it, or it could be a random output between these 5. Obviously, you can double click. No, you can't double click this. Well, essentially, this is what it is, right? You send something in, and it comes out on the other side in a random position if you decide to do it like that, or it's going to be looped as well. And you can choose which index you want to send it first. Obviously, -1. -1. Why is it -1? It should be 0. I'm not sure why it's -1, but basically, you start with an index, and whichever index you're using, you will kind of be, going out here. And of course, you can reset the whole story. So I'm going to leave it over here because why not? This print string, no point. I'm not going to utilize this gate, of course, because I kind of need a little bit more logic, and it's just kind of pointless. Right. That being said, let's go with the second situation here, which would be our, actually, let's do let's do the execution first. We're going to do the loops last. So here's our execution. I will need to utilize some more screen space, so I'm simply going to have it here. And there's my spacebar. Somehow it got grabbed, which is cool. I'm going to disconnect this over here, and we're going to use some of these things. So as you can see, this is an execution. At least that's how I categorized it. This is an execution dependent. These are execution dependent nodes. All right. So the do n essentially allows you to press something and then do something n amount of times. Therefore, it allows you to, let's say, I want to do something 5 times, right? And I want to print whatever. Let's just say print string again. And I'm going to say hello, compile and play. Spacebar, hello once, hello twice. And that's it. As you can see, I pressed spacebar 5 times and nothing happens. Okay, so this is kind of like a restriction to whatever it is you're doing. So if I wanted to do it 3 times, of course I could do it 3 times. By the way, you could also have a counter. So let's say hello, and let's say I got, no, let's do it like that. Okay, let's append. And I'm going to grab the counter. For example, in this case, I will say, I have, and then the counter, and then another append. And I'm going to say bullets. Well, in this case, I do want to actually do it like that. Bullets left. Okay, and I'm going to do it like that. So when I print the string, it should tell me how many bullets I have left, with the bullets being the counter here. So let's make this 15 seconds again. So we got 3 bullets. Let's just say we still got 5 bullets. Compile and play. I have 1 bullet left, 2 bullets left. Well, I kind of need to reverse it, but I hope you get the idea. Okay. You inverse it, of course. You start with the highest amount. Get the n, so this would be, n would be, for example, your bullet count, right? And then you would simply reverse it. But essentially this means that you get to do something, perform something 5 times, and then nothing's going to happen unless you reset it. So of course you could reset it every single time when you sprint it, which is going to turn into a loop. Kind of defeats the purpose of it. So you might have to have some other logic, such as, I don't know, some branch. Okay, and if something is true, like whatever you do here, it just says true when n is equal 5 because you use the counter, right? So you could say, I don't know, if, well, you can use a comparison here. So if this is equal to 5, where is it? Okay, this is not how we're going to do this. Let's try it another way. Equal integer, there it is. So if this is equal to, let's say, 5, right, this is going to turn into a true condition. So we could drive this over here, right, and then it will execute. But then again, you need also a thingy. So this kind of have like one of the events will fire off. So we'll have something like this: 1 2 3 4 5, and then 1 2 3 4 5. 1 2 3 4 5. So fairly simple, right? Nothing fancy here when it comes to these. Next we have a do once. It is essentially a do n, but n is only 1. So there really is nothing to be done. So once you do something once, you're done doing it forever. And as you can see, I can complete it, and once it's completed, it will just say hello, and we'll say goodbye. That's it. Nothing else. That's what do once does. Very simple as well. Next, we're going to use a do once multigate. This will essentially give you have several pins, allowing you to. It's just like having several do ones, but you have several requirements. So you do once when I press it, and you do it once when I release it. And when I press it, I'm just going to say, well, here it is, pressed, print string, pressed, and released, right? And I'll simply fire it off depending on which side I want to come in and come out. Obviously, you can reset the ins and the outs. Compile and see what happens. Press, and release does not fire for some reason. Let me see what's the story here. Beyond. This should, oh, okay. Oh, I did it only once, my bad. But this should fire off both of these. For some reason, I'm not really seeing it. So what's going to happen if I keep this at 10, and I keep this at 5, and this is going to be some other color. Let's compile and save and play. Maybe you need to reset it. Oh yeah, you need to reset the out as well. I think this is getting, I think this gets reset the moment you, actually this, can I open this? No, I can't open this. It's a K2 node. Right, look, it's a, you might want to use this at some point, but generally speaking, I've used this only once. I've only done it once, you know, it might be useful for whatever it is you're trying to do. Obviously, you can have way more pins than that. And then you've got the retriggerable delay and the regular delay. Now, the delay is actually a very useful tool. I find myself using it quite a lot. Now, the delay, of course, does exactly what it says on the can. It can print the string after a particular delay. So I'm going to say hello after, let's say, 3 seconds after pressing the spacebar. I'm just going to compile, play, spacebar, 3 seconds, hello. Right. If you do the retriggerable delay, it allows you to reset the timer if you press the spacebar button. So, or whatever condition fires off into it. So let's say you've got a 1 second delay, and I can simply play, press spacebar, 1 second, hello. Now if I press spacebar again, and I keep spamming it, I'm simply resetting, right? I'm resetting the counter until, of course, I fail to do so, and will fire off, okay? So this would be something like a dot. Like if you have a damage over time event, you would use a retriggerable delay, for example, which would, let's say, you know, as long as it's not firing, you will deal damage. You could use this reverse logic, okay, where as long as something is inside an AOE area, right, this will not continue firing. And until this fires, you could have a Boolean, for example, which says, right, we're under fire, we're on fire, we're on fire. And if you're on fire, you'll be receiving 50 damage per second. And when it's completed, it will set you on fire to false, meaning that, you know, your player is no longer on fire. So, you know, you have your delay would be how long your player will be on fire after he exits the area of effect. Something like that. I don't know. You can use it for whatever you want. It's just a way of manipulating execution flow. Okay, that being said, we're going to have to go over to the loops, and these are our loops. Now, for loops, we need an array. Whenever you talk about an array, you talk about loops. Whenever you talk about loops, most of the time you talk about an array. So we're going to have to create an array, and I'm going to say that this is my, I don't know, what is this going to be? My grenade count. Okay, this is going to be my grenade count. It's an integer. Of course, this could be anything, by the way, right? It doesn't have to be an integer. It could be maybe a string, maybe a set of strings, right? But once we compile, you need to populate your array, okay? And I'm going to say that I got five grenades, in this case, 4 indexes. So I'm going to say 1, 2, 3, 4, and 5. You got these drop down buttons here, which allows you to insert, delete, duplicate stuff. But that's not what we're going to do. And we'll simply drag and drop this using control. So we got this. Now, what can we do with our array? There's a bunch of functions with array when it comes to stuff, allowing you to get the index and all of that. But generally speaking, if you have a condition, let's say with while loops, for example, we could use a while loop. We could run the loop itself. Now, that's actually important that you be very careful with while loops, because it's possible to have an infinite loop. Because if this is true, that is it. Like if this is true, I'm firing it off, and this will not stop looping until I do something. Okay, so I need to set this condition to false at some point. So in the loop body, I could have something like, you know, print string, and the print string is going to say hello. And once it's printed, I'm going to say, well, do something, right? And then I could say, I don't know, maybe we could have some kind of other, like, it's pointless if I don't have something else here, because I kind of need to set the Boolean to be false. So I need a variable, etc., etc. But I hope you get the point, okay? I can't be arsed with this right now. But this is fairly simple, right? It's just whatever you do in the loop body is going to be executing until the condition is true, and when it's false, it's false. And once it's completed, you can continue execution the regular way. A for loop is a little bit different. It allows you to actually loop through something, in most cases an array. So if I grab this array and I get its first index, so in this case I get last index, so this would be my last index. I'm going to dunk it over here. My first index would be, let's say I want 5 indexes. I'm going to start through from the second one, so index number 2. So I'm only going to loop twice or 3 times. And when I press, I'm going to start the loop. And the loop body, I'm going to print the string. And I'm going to say in the string, well, I'm simply going to print the index. So let's see what index we get. We got 4, 3, and 2, or 2, 3, and 4, which would be the last 3 indexes. And that's how we're looping through the for loop. And then, of course, once it's completed, we could continue, let's say, with the for loop with a break, which is exactly the same, by the way, allowing us to break it before we're done, though. So if there's a condition that if this loop, for example, keeps looping and then we break it, it could do something else, which is what it is. Now, we got a for each loop, which is also pretty interesting. Here, it allows you to, this is specifically for arrays, by the way. You will notice that it takes, instead of taking an index, because an index allows you to target a particular thing, not to mention that you can have this index, the first index be, like, say the starting position or whatever. You can have array length. So however many, how many of these do you have? This would be your last index, for example. Actually, in this case, it won't, because it'll be one less. But you can do a bunch of operations with arrays, and they're very useful. So in this case, I'll grab the array and simply put it in the array here. So I have an array. Now for each, basically that's what this thing says. For each array element, we're going to have to do something. So I'm going to print the string, and we need to print something, and I'm going to say, well, we can either print the index itself, so something from 1, 2, 3, 4. I really should have changed maybe this should have been strings, and let's change this to string. Let's change this to string. I'm going to change the variable type, and this, of course, has been changed, I believe. Now I need to recompile this. Why does this no longer exist? Unknown. Oh, come on, dude. Are you joking? Oh yeah, we need to, once it's compiled, we need to actually initialize it. So let's say we have, I don't know. Maybe this is an array of ammo types. So let's say armor piercing, and then we have hollow points, and then we have just full metal jacket, whatever, and then we have, I don't know, anti-personnel. And we can have anti-vehicle. So, something like that. I don't know. And why do we not get this? All right, I'm just gonna get another one like this. Now, of course, every bullet is anti-personnel, but the point is that I just wanted to have something that represents each of these values. And now each array element, as you can see, can be printed. And of course, it can print the array index while it's looping. Let's play. Press space bar. We've got all of the appropriate pieces. And of course, we could grab the index and do whatever it is we want with the index. Maybe we could use a for loop for this index, right? We can use the array index here and use it for our first index here, and then do something else with a for loop, and then maybe use a last index, right? Whatever. So it's pretty interesting. All right, maybe you can have it in the last index and loop 5 times, depending on whatever it is you want to do. So there's really loads of different possibilities, and once it's completed, you will continue your execution line. Then we have the for each loop with a break, which is pretty much the same thing, but it requires some logic to break it up. Well, it doesn't have to be broken up, but you could break it. That's the idea. And then the reverse for each loop does Well, that's exactly what it says on the can. It will reverse the count. So in this case, maybe I should have just made you take note of this. Let's compile and play. Press spacebar. First is AP, then HP, then this and that and that. Okay, so AP and HP is first. Armor piercing, hollow points. In this case, it will actually be the reverse order. So if I go ahead and do this, and do this, and do this, this should be in the reverse order. Compile and save. And as you can see, the first is anti-vehicle and the last is AP. So this is the reverse for each loop. Now, again, it depends on what you're using this for, but these all of these together combined, you know, have very powerful effects. And you can really control the flow of your execution line. In other words, it allows you to have like loads of branches and all sorts of different sequences. You can have quite a lot of stuff on a single execution line, because again, remember, the event tick is only one execution pin, so you need to split this up. Whether you're going to do it in a flip-flop fashion, whether you're going to do it using a sequence, right, or a branch, or anything really. Like you need to somehow split the execution line if you don't want to be stuck just on one line. If you want to do several things at the same time, right? If you want to assign a couple of variables or get a couple of casts, we'll be talking about that in the next video. But in general, these are your execution flow control nodes. If you want to find them, just type in flow, and you'll see this is the flow control bit without the enumeration. Oh, Jesus Christ. These are switches, by the way. These are switches which allow you to switch stuff. It's kind of like the if statement, the one I said, but you do need an enumerator for it. Do we have an enumerator though? That's the question. Yeah, we do, I think. You can add a bunch of pins, which would be cases. So in case of whatever, we have, in case it's 0, we do this. In case this is 2, we do this, etc., etc., etc. Okay, and assuming, of course, you have an enumerator, which will be a much better thing. I do believe, do we have an enumerator? I thought we did. Yeah, we do have an enumerator, so we could perhaps use weapon types. So we could use switch, actually just weapon types. And there it is. We're going to switch on weapon types. And look, you can actually loop. You can use, by the way, enumerators for loop. I kind of forgot to mention that. As you can see, you got utilities. You can for each on the weapon type. So as you can see, you can run this loop here without actually pumping anything into it in terms of a for each. So that's comfy as well. Make sure to not forget that whenever that's why enumerators are valuable, because you can see we got sword, spears, and depending on what we have selected here, so we could be looping in this case, right? So we're running a loop, and in the loop body we'll be doing something like this, the switch, right? And the enumerator value will be responsive for this. Then when we have a sword, we'll say, I don't know, this is a sword, this is a club, right? I'm not going to make a bunch of print strings out there, but I hope you get the idea, okay? It should be fairly simple to grasp. Okay, that's it, guys. We'll see you in the next video when I talk about blueprint communication, which will be the last video in this series, and we can actually start, developing after that. All right, thanks. Bye-bye.